right? It's not about getting another degree, right? That's like a big 20%, part of the pie, right? If in that time that you spent getting your degree, if I just spent a bunch of time getting my 1% down, I've surpassed you already.
Hello and welcome to the Being an Engineer podcast. We've got a special edition for you today. In fact, it's a 3-part mini-series, and today is episode 1 of 3. And this mini-series, Brad and I are going to focus on the topic of how to accelerate the speed of engineering. I'm excited for this because over the past 5 years and 300 plus episodes, I have heard recurring patterns emerge from different engineers at different companies in different work environments, but these best practices have come up over and over again. And so we've identified 21 of these best practices related to how to accelerate the speed of engineering. So today we are going to go over the first 7. And then in episode number 2, we'll do numbers 8 through 14. And episode number 3, we'll do 15 through 21. So today's focus, there's a light focus on the individual. How can the individual accelerate the speed of his or her engineering? So without further ado, let's jump into that. Brad, is there anything that you want to share before we dive into these first 7 best practices?
So, for those that don't know, my first appearance on the Being an Engineer podcast was during Aaron's Accelerate the Speed to Engineering series. And, he approached me and, basically said, I think you kind of know what you're talking about, or maybe not, but let's give it a shot to see what you have to, what you have to offer, what you have to share with everybody. And ever since then, this topic has really been just percolating in my head. And why is it that good teams can move fast? I read a lot, and you read these books about like the early days of Apple, and you read about Skunkworks and what they were able to do at Lockheed, and you start to really think about not just from the leadership standpoint of why they were able to move fast, but what did it take for each person to actually function in those types of environments? It takes a special person. And I think what I'm really excited about is that, Aaron's had such a vast number of people from different backgrounds, from different life experiences on this podcast. And I'm really excited to hear and to really just narrow this down into these bullet points, just so that we can continue on our mission, which is to, really to help disseminate this knowledge and help have people apply this knowledge to their actual work. So, with that being said, that's a lot of words. Let's get started and let's jump right in.
Yeah. All right. Just a little bit more background before we share best practice number 1. As I have gone through these 300 plus episodes, one of the explicit questions that I have asked over and over is, what is one way that you have accelerated the speed of engineering to our guests? And like Brad mentioned, we actually did a series where that was the focus of the questions I asked to the guests. I think there were probably 6 or so episodes where we just talked about that with 6 different guests. But outside of that, more generally, I would often ask that question. It's just one of the questions in the episode. What's one way that you have accelerated the speed of engineering? And throughout all of these episodes, whenever I heard something, even if we weren't explicitly talking about that topic, but whenever I heard something that was relevant to that topic of accelerating the speed of engineering, I'd write it down in OneNote. I just kept this list in OneNote. And over time, it grew, and I started noticing these patterns that I would have written down maybe a few different things in slightly different words, but they were kind of the same thing. And so over 5+ years, this list has grown and then condensed into these 21 best practices, and that's how I came up with them. So number 1, best practice number 1 for how to accelerate the speed of engineering is use the right communication medium for urgency. Now, a lot of engineers, myself included, don't naturally have the skill set of talking to other human beings. Maybe we prefer to be in a quiet room by ourselves, just pounding away at a keyboard. But when it comes to human interaction, that can feel uncomfortable to some of us sometimes. And so I get it when an engineer wants to send an email instead of calling a person or walking over and talking to a person. Um, but this is one of the biggest and lowest hanging fruit items that I have heard over and over, not just from guests on the podcast, but I see it in my own company with my own team. I cannot tell you, and it makes me sad to say this because I talk about it all the time, even with my own engineers, and I still see it happening. When there is a sense of urgency, you need to get something done quickly, and you're relying on someone else. I'll ask an engineer, hey, what's the status of this part that we're waiting on from vendor ABC? Oh, I'm not sure. I sent them an email. I'm waiting to hear back. And I just want to pull my hair out because they know that there's sense of urgency that we're waiting to get this part. It's a critical part for a build, whatever. And they send an email instead of just picking up the phone and calling the vendor and saying, hey, I need to get this part tomorrow. What can we do? Instead it's sending an email and hoping that they get back to you, which usually does not work out well. So that's item number one. Use the right communication medium for urgency, which if you can visit someone in person or just walk to someone's desk, that's the best way. A phone call is a good close second. Uh, Email has no place in communication when you're trying to do something urgently, unless that's just the only alternative. So
But
that's item number one. Brad,
this,
anything to add to that?
in this day and age, email is not the only and really not the right communication medium for most tasks. I mean, there's so much to say about what email has unlocked for us, but there's also this kind of inundation of stuff, right? So you're working for an 8-hour day. I mean, even myself, right? I might get 50 emails in a day. Some of them good, some of them I need to reply to, some of them just are sales calls and or sales emails, and some of them are advertisements. And so it's like part of that spending the mental energy of shifting through what is actually relevant, what do I need to do, what can I just ignore, that side of it, it just is not efficient, it's not effective. And I think the point here of calling or walking over or having that in-person conversation is great, and I think both sides will appreciate it. And I think that's the one thing that I want to point out is, you know the thought of like, oh, maybe this is urgent for me but not urgent for you, or um I don't really want to bother you because I know that you're really busy. It's like, if I'm able to get a question answered quickly, and that moves me forward and that advances the project or the product or whatever I'm working on, that's going to make both parties appreciative that I actually took the time to walk over to your desk and ask you a question or to give you a call. So don't ever think that, oh, I'm just a nobody. I can't, I can't be calling this person and asking them for stuff. That's not true. Take the time to do it.
When you need to get something done quickly, stop emailing. Don't email. Pick up the phone and call the person. All right, we beat that horse to death. Number two, ask for help early. Now, as engineers, we love solving problems, right? That's why we became an engineer, because we love solving technical problems. And so it can be tempting to go down this rabbit hole by yourself and keep digging further and further and to try and solve things on your own. But when you get stuck and you're just spinning your wheels and taking more time, you have to stop and you have to ask someone for help. There was a situation, this was a few years back, where one of our engineers was trying to bring up a pick and place, SCARA robot. And we had, all the equipment in our office, and this engineer was out in our warehouse trying to bring this system up. And shame on us, the leaders of the project, for allowing this to happen. But the engineer probably spent a couple of weeks trying to get this working. And um, this is a different topic of conversation altogether. Those who were in charge of leading the project didn't step in earlier and say, "Hey, why is it taking so long?" You know, and there were some small check-ins here and there, and the engineer, I'm trying to figure this out. But after several weeks, there really was hardly any progress made on this, and we're like, how does this happen? 60 hours or whatever that's been working on this, and we're not much further along than we were in the beginning. And come to find out that this engineer, he'd been, dutifully looking through online forums and reading things and trying to figure out on it on his own, but he'd never done it before, and he just couldn't find the answers. And eventually, we stepped in and said, okay, stop working on this by yourself. Call the support representatives, the manufacturers of this scare, and just ask them how to do this thing. And the engineer did that, and literally like a 15-minute phone call had it up and running, But it can be scary, I guess, to ask for help, because it makes us feel like, oh, we're not good enough, or the team is relying on us to figure this out, and I have to be the one. But that's just not the case. I mean, from a leadership standpoint, I am far more appreciative of an engineer who understands when they have put enough of their own time into solving a problem and need to just ask someone else for help than I am the lone wolf who just wants to figure it out on their own, come hell or high water. So that's number two. Any additions there, Brad?
This is a really big, I think, early career lesson that you need to recognize in yourself. This was that story, that was me. 10 years ago when I first started, I had this feeling that I needed to know, I needed to be that problem solver. I needed to figure out how to do things on my own. And then asking for help was almost like a sign of weakness. There was a lot of fear in that, right? What if I'm not competent? What if they think I'm not competent? But I think the really key learning for me was to very early on in whatever project that I'm starting was to give myself a realistic time frame around this is my exploratory period. At the end of this exploratory period, I should either have it working or I should know what the heck I don't know, or I can't get to work, or I just can't seem to understand. And that's when I go and I ask for help. And now that I'm further on into my career and I'm starting to lead younger engineers, what I'm telling them is don't come to me and say, I don't know what to do. That doesn't help, right? What I appreciate is I want you to go and try to solve the problem and then come to me and say, this is, these are the one, two, three things that I can't figure out, or I can't get to work, right? This is what I've tried. This is what's not working. That is so much more productive than spinning your wheels and spinning your wheels and spinning your wheels and trying to just figure something else out and then kind of throwing your hands up and going, I don't know what's going on. Right. So this is a really great early career lesson. You are not weak for asking for help. Ask for help.
Absolutely. Please, I am begging you, ask for help. It's not a sign of weakness. And to Brad's point, I'm not suggesting that you just get help immediately, right? You shouldn't just go to your peers, your manager, whoever, and right away just, how do I do this? You asked me to do this thing. I don't know how to do it. How should I do it? That's not what I'm suggesting. Again, what Brad was saying, give yourself a timeline, right? And this is going to vary depending on the task. If it's a relatively simple, maybe kind of low impact task that you've been given, maybe that timeline is an hour. And if you can't figure it out in an hour, then go ask someone. If it's a much bigger problem that's probably more high impact on the business, on your team, then maybe that timeline is, a few days or even a week. And this is something that you can and should discuss with your manager. What's an appropriate amount of time for me to spend on this before I ask for help? And I promise you, your manager will be so grateful that you had that conversation versus you just spinning your wheels.
Right. And Aaron, I want to make one more point here. You know, I think you've heard of Tony Robbins. I think everybody's heard of
Mm.
Tony Robbins. You know, and you can agree or disagree with what he has to say, but one of the one of the things that he really pushes, especially in some of his most recent conversations and podcasts and talks that he's been doing, is that your greatest asset is pattern recognition. And as you grow in your career, the reason you become more and more valuable is because your pattern recognition becomes greater and greater and greater. So it's not about solving the same problem over and over. Yes, there is some of that, but your ability to recognize we've already done that, we've already tried it, we've already gone down this path that led us nowhere, and then we had to kind of take a U-turn and go down this other path. That is your greatest asset. And the thing is that in early career, you know, really anybody who's working on a team and working with other people, it's really, really important to leverage their patterns and leverage what they recognize has already been done in their career. And like Aaron said, have that conversation. Hey, this is a novel problem to me. Have you solved something like this before? And a lot of times they can say, I did something similar and I tried X, Y, and Z, and that really didn't work for me. But what I did found that worked was going down one, two, three. You know, and that, you know, we talk about speed, right? You now have a jumping off point where you can start down that right path and understand where you're going, and then ask better questions in a faster way. You know, and the other thing I want to point out, Aaron, I'm sorry, I just so many thoughts on this. This pattern recognition portion, as you jump into leadership and as you have better patterns in your mind for how these things should be developed or done, when you start to delegate tasks out, whether you say it or not, there is always that thought in the back of your mind that, okay, I'm giving this to you. Last time I did this, it took me about 3 weeks to do it. Okay, I kind of have an expectation. I'm going to kind of say, okay, 3 to 4 weeks is what you should take to come to that conclusion. That prediction came from somewhere. And so if you're being given a task and it's, you know, somebody saying to you it should be done in 4 weeks, if you don't see what it's going to take to get that complete in that 4 weeks, ask, because they already have gone through it and that's how they've gotten that prediction or that, you know, that timeline in their head, and it'll just lead you down the right path, and then that gives you a pattern that you can then recognize for the next time that you do it.
Yep, it's not a sign of weakness, it's a tool for productivity. So just ask for help early. And let's back up a second here and ask the question. We're talking about how to accelerate the speed of engineering. Why? Why do we even care if we accelerate the speed of engineering? What's the value in that? And this, I think there's two answers. There's kind of an altruistic answer, and then there's a commercial answer. The altruistic answer, for me anyways, the faster we can do engineering, the more good we can bring to humanity. You look around us and pretty much everything that we interact with on a day-to-day basis outside of the people was developed by engineers. And all of these benefits that we have, the phones that we use, the cars that we drive, how our food is delivered, plumbing, all of these things that came through engineering. So if we can accelerate that speed, we just improve the human experience by that much. The commercial point, which probably is the more salient one for just everyday life here, is the fact that engineering is part of a business. And you might not like that answer, but it is true. And your value as an engineer is only as important as your ability to contribute to that business that you're a part of. So when you're trying to do something on your own and you're just spinning your wheels, you are not helping your business. It's a detriment to the business of which you're a part. But when you can identify, I need help, I'm going to go ask for help, that helps you move things along, work quicker, and meet business objectives more quickly. Again, probably a dirty word for some of you, right? You're engineers. Who cares about the business? Well, I'll tell you what, buddy, you better care about the business, because when times get rough, and they do from time to time, you're the one who will be jettisoned if you don't have a keen eye on how you specifically help the business, not just do the engineering work.
Yep, and it's going to help you in interviews for your next job. So
Brad knows about that. Yeah. All right. So let's see. Number three, so this is within the context of troubleshooting a system specifically. When you are troubleshooting a system, don't troubleshoot the entire system in its entirety. Troubleshoot individual components. So that means break the system down into its individual parts or subsystems, and test those individual parts or subsystems by themselves. I'll give you a practical example of this. Years ago, I was working with a multi-axis vision system. So there's a camera, and there were three different axes of motion, X, Y, and Z axes. And the camera was not ending up where it was supposed to, right? It would take a picture at the end of its travel, and that picture was not where it was supposed to be. That was very clear. Why it wasn't where it was supposed to be was far less clear. Was it a problem with the X axis of motion, the Y axis, or the Z axis? And embarrassingly, I probably spent 3 or 4 hours troubleshooting the system, could not untangle this mess of motion axes. And finally, it dawned on me that, oh, I'm such an idiot. I need to just break these down into their constituent components and test each one individually, which I did. After which it became painfully obvious where the problem was. It was so obvious. It was in, I can't remember at this point, but it was the y-axis. Something was wrong with the y-axis. It was a defective part, I remember, uh, coming to the conclusion ultimately. And as soon as I replaced that y-axis, everything worked great. But I spent hours trying to troubleshoot the entire system. Couldn't figure it out because there's just too much going on at the same time. But as soon as I broke it down to the constituent parts and tested each axis by itself, it was just so clear, so easy. So when troubleshooting, break things down into their constituent components. Don't try and troubleshoot the entire system at the same time.
and this is a skill. This is something that you need to practice because it's so easy when you're looking at your entire assembly or something to look at things as a system, because that's where you're thinking, right? Where your thinking is going. For me, the biggest example of this, I've got my first taste of doing like a complex console assembly. A lot of printed circuit boards, everything kind of interact. You had wires going everywhere, plugging in, and we had a day where we blew a fuse, and I, in my world of things, I was looking at, okay, how do I figure? I couldn't even figure out how to figure this out. It's so complex. There's so many things going everywhere, and I had a kind of my counterpart systems engineer that was working on this, and the first thing that he did was he pulled up a schematic, and he looked at, okay, well, the signal, I don't remember what it was, but the signal came from here and it went to here and it did this and it did that, and in the time it took me to kind of freak out and say, oh my god, there's so much to do, and what am I looking at? He had already diagnosed the problem. So exactly as you're saying, right? He took it down from this big to this big, and he was able to kind of get to that answer very, very quickly.
Yeah. Yep. Great. All right. Number four, use simple experiments and basic instrumentation to guide decisions with measurable data. Data is so invaluable when it comes to making a decision. This could be part of troubleshooting. It could be part of just standard R&D development, but use data, use instruments, acquire data, and then use that data to make decisions. Don't make decisions based on your gut feel, or I think this is the right approach. I couldn't come up with a great example, real world example for this one just off the top of my head, but when we talk about basic instrumentation, we're talking about things like a force gauge or a pressure transducer, maybe an oscilloscope, things like that you can use to acquire measurable data, and then you use that data to guide your decision.
I think the most important part here is you said simple experiments and basic instrumentation. So simple and basic. And the thing is that the more complex you go, you add variables, right? And the that in of itself is just that complexity is can muddy your data, right? And at the end of the day, you have to ask yourself, does my data actually tell me what I want it to tell me, right? Numbers and arithmetic, they're great for understanding what's going on, but they're inherently dumb, right? You can get a bunch of numbers that aren't usable to you, right? So I think the key here is keep it simple, keep it basic. And then if there is necessity after you kind of get that first round going, then expand into something more complex, but simple and basic. That is the key point here.
Right. Yep. Okay, these next two are pretty closely related, but there is a kind of a nuanced difference. And uh, instead of 5 and 6, you one could say that this is more like 5A and 5B. But anyway, uh, number 5 is buy instead of build whenever possible. So you're not reinventing the wheel. We built a fixture, I don't know, a year ago or something for a company. It was just a simple metrology fixture. We needed to hold some parts stationary, and the whole fixture got mounted into a CMM, and then the CMM probe came down and touched off on these different parts to collect data and make measurements. And the most efficient way to hold these particular parts was using a three-jaw chuck. And engineers, we love to design things, right? That's part of why we became an engineer. It's fun to design something, but it's also expensive to design something new. And so if you can just buy something off the shelf and use it instead of having to design something from scratch, you should do that. Just a great way to accelerate the speed of engineering comes down to the business metrics, really. So we just bought some of these three-jaw chucks off of McMaster and stuck them on top of our fixture, and boom, we had a great fixture that worked perfectly when, you know, we could have spent time to design our own three-jaw chucks and just it wouldn't have made sense. It would have been a fine product in the end, but it would have taken us way longer. So whenever you can, buy instead of designing something from scratch.
Yes, I had a mentor engineer who I've kept in close touch with. And he, I guess he didn't really know it, but he subscribes to the IDEO style of thinking where you think broadly and then bring everything inwards. And so he, when we were going through and thinking about fixturing, he would always tell me to start by being as imaginative as possible. I want to solve this problem, with the Rolls Royce of fixtures, right? I'm going to custom this, I'm going to custom that, and it's going to move here, and there's going to be sensors and this and that. And then he said, then start to think what can be replaced by off the shelf components. And that has always been a really good way of for me to think. I'll spend the first 30 minutes thinking about designing the nicest, beautiful thing out there, and then I'll bring it in. And eventually, what I come down to is, maybe I have two or three 3D printed parts that are just holders for a bunch of stuff that I buy on McMaster, and it works perfectly fine. And I think that's been one of my greatest learning points is you don't have to be the most flashy, right, to solve the actual problem.
I recorded a podcast interview yesterday with one of our team members, Matt, and that'll come out in a few weeks. It was exciting because it was the first time we used our new Pipeline Media Lab, which is a fancy media studio that we recently built to record a podcast. Anyway, Matt is brilliant. He's been doing this for 30 years and he just has so much experience. And one of the things he said just matches exactly what you just mentioned, Brad. He said he was talking about the importance of designing by subtraction, not addition. It can be so tempting for us to add things and add things and add things to our design. But what he always tries to do, like you said, come up with the Rolls Royce, right? What would the ideal solution look like? And then, okay, what can I subtract or replace with something off the shelf? And keep doing that. There's a lot of complexity there. How can I get rid of that complexity? So design by subtraction, not addition.
Yeah, that's a great framework. I'm going to use that from now on.
All right, here we go with number six, or 5B, if you want to think about it like that. So this one is also about using off-the-shelf products, but it's specifically within the context of prototyping and R&D. So you're not trying to build a final production unit of something. You're just trying to prototype, and you're going through development, right? Um, and we had a great example of this recently at Pipeline. We're working on a medical device, and this medical device utilized some kind of like soft cushions, like some soft goods materials. And we're not soft goods engineers at Pipeline. We're great with metal and plastic, maybe some rubber here and there, but we don't work with soft goods. So we could have messed around and maybe even hired someone to come in and like sew some of these soft goods, these cushions together for this device that we're working on. But it would have taken a long time and it would have been really expensive. So instead, our engineer went on Amazon and found a similar product and just bought it. It was like $60 or something. And it had these little soft cushion pads on it. And we just took those off and put them on our prototype. And now, boom, we had like a finished prototype complete with these little pads. And it worked great. And, $60 to buy something when you're talking about billing hundreds of dollars an hour for engineering time, and you can just buy something for $60 and reuse those parts. It's just a no-brainer. So in the context of prototyping and development, also buy something off the shelf and just tear it apart and reuse it instead of trying to make something custom.
Yeah, and I'm starting to realize too that, we're I think I'm growing in my career in a very interesting day and age where there's not much left out there that is completely novel. In some way or another, it's been done, maybe not for the exact application that you're using it for, but it's been done somewhere. And this is a great point where you don't need to always be the most inventive, the most innovative in your job. Sometimes it's going to take that, in order to solve a really novel problem. But there's always a benefit to you to learning from what else is out there or using parts that have already been developed and are being sold commercially. It's never going to hurt your process. In fact, there are entire businesses out there who their entire business model is take what's already out there, reinvent it one for one, and then make a small tweak, patent it because that's all you need, and then it goes out into the market, right? That's why you have so many of the same thing and so many options nowadays, right? So, you know, I think that this is a great point that you don't need to always be the most innovative. You can use what else is out there. Somebody's probably already thought it through. That has been, you know, that's has way more experience or is way smarter than you. So why not leverage their experience and their time?
There's a quote, I can't remember exactly how this goes. I'm going to mess it up a little bit, but it's something like good artists create, great artists steal, right? Just use what's out there. It's so much faster when you can. Okay. Number seven. So this is the last best practice that we will discuss today. And this one might be a little bit controversial, actually. I could see some people maybe pushing back against this. So it'll be interesting to hear what kind of comments come out. But number seven is work more. Just don't overlook the value of working long hours. Now, obviously, there needs to be some kind of balance, right, between like personal life and work life, and we don't want to work ourselves to the bone and burn out, right? That's not productive for anyone. But there is something to be said for at least for specific periods of time. Maybe you're in a crunch and you need to work a few extra hours each week. Or um, uh, going back to this interview I did with Matt yesterday, one of the things he talked about and he is such a good engineer. Like he's cream of the crop. This is the kind of engineer that any engineer should aspire to be. He knows so much. He's so good at what he does. And he talked about how he's just naturally curious and he wants to learn about these things. And he regularly spends his own time reading books and just learning about different technologies out there because he finds them fascinating. I worked with a young engineer years ago who was ambitious, but also wanted to take shortcuts. And I remember him coming to me one day and saying, Aaron, how do I get better faster? How do I accelerate my progress? And my answer to him was, you probably just need to spend more time perfecting your craft. You just need to work more. Like there's something to be said for just getting those reps in, you know? So don't overlook the value of just working more. There's a balance. Don't push it too far, but 40-hour work week, maybe you spend an extra hour a day, and you have a 45-hour work week. Like that shouldn't kill anyone. And that extra hour a day, the cumulative compounding effect over time will be enormous.
And I'm going to add to this again from personal experience. You have to have intentionality and focus if you are going to do this. So in Aaron's example, that young engineer, he wants to develop his craft. So working more, meaning maybe taking an hour a day to do extra CAD practice, to be a little bit more efficient in your style of CAD. Or if somebody is really wanting to be a leader, right? Maybe taking an extra hour a day to watch a TED talk or take a leadership course online, right? There has to be intentionality. Where this fails is if you just think, I'm going to put the hours in, but those extra hours don't really do anything for you. So you're thinking, oh, I've worked 10-hour days for the last year and I don't feel like I've done anything. Well, what did you do with those extra 2 hours, right? Or because you worked 10 hours, did you feel like you could take an hour and a half lunch and, five 15-minute breaks and you're on your phone? And, was there no intentionality in what you were doing? So this, I think, only works, and I'm not discrediting this point, but I think this only works if you are able to really focus in and be intentional with what this more work, more time does for you. And as you get into different seasons of life, things change. I've recently transitioned to being a dad, so I have a young son, and you know I think that I spend probably 7 hours of working time a day, but I think that 7 hours, I've been more productive in the last couple of months that I've been working than in my last role where I was working 10 hours, right? Because I'm intentional. I know that this is my working time because I have family time coming up, right? And so that intentionality really makes a difference in your development and then how fast you can go.
Well said. I think that's a great point. The intentionality. It reminds me of a funny story. Way back when I was in high school, my friends and I, we started lifting weights. Of course, they all got big, and I never did because my genetics just aren't there. But anyway, we started lifting weights, and there was this one guy who was part of the group, and after a few months, we all noticed that like he had gained some weight, like put some weight on, not muscle weight. It was mostly fat, and we're like, "What's going on with you? Like, uh, how are you just getting fat?" And he says, "Well, I've been taking this weight gainer, this weight gainer shake. I've been drinking it every day." And we're like, "Okay, and like what else?" He's like, "Well, that's it. I just take this weight gainer shake, and I thought it was supposed to make me stronger." This guy wasn't even working out. He was just drinking weight gainer every day. So yeah, there needs to be intentionality and some kind of plan behind the extra time that you spend.
Oh, the high school days.
The high school days, yeah. All right. Well, there you have it. 7 points. So, quick recap here. Number one, use the right communication medium for urgency, which is generally in-person conversation or a phone call. Number two, ask for help early and time box those solo problem solving situations so you avoid going down rabbit holes for too long. Number three, when you're troubleshooting a system, break that system down to its constituent components. Don't try and troubleshoot the entire system at once. Number four, use simple experiments and basic instrumentation to gather data that you can use to make decisions. Number five, buy instead of build whenever possible. And number six, when you're prototyping something, again, buy products and just use those in your prototypes. Ultimately, you'll probably have to design something yourself for production, but when you're just doing R&D, buy what you can off the shelf, tear it apart, and reuse it for your prototypes. And number seven, work more. Don't overlook the value of just putting in the extra time, getting those reps in with intentionality, like Brad said. So that concludes episode 1 of 3 for our mini series on the best practices of how to accelerate the speed of engineering. Thank you so much for being with us today. And Brad, any final comments before we close here?
Yeah, can I give them a bonus one? Something that I've been thinking about.
Please.
So I've been thinking about this a lot, and I think a lot in sports terms. I love sports, and grew up playing sports my entire life. And one of my favorite books is called The Inner Game of Tennis. Never been a tennis player, but if you've never read that book, it's just about how you know tennis is such a it's a sport where you're one on one, points come and go so quickly. I think Roger Federer is quoted in there saying that the best tennis player arguably ever to play, he only won 53% of his points across his entire career, right? So how did he keep his mental game strong over that other 47%, right, of his playing time? And one of the things that's really harped on in that book is all of the top athletes put a lot of focus into the small, boring, mundane things that a lot of people overlook. And that in of itself is what makes their game in totality so much greater than their competition. And I think when you apply this to a business sense, you apply this to your time being an engineer, or whatever you're doing currently, think about the small things that you've just been kind of let slide, right? For myself, I'm thinking about, like, I really wanted to, get this part quoted out. And so when I made my drawing, I kind of half-assed everything. I didn't put tolerances, I didn't finish my drawing, I didn't pull a part number, whatever it may be, right? And what did that lead to? That led to me sending the part out to the vendor coming back with questions, me having to answer the questions. 3 4 days go by, and I don't have a quote, right? But if I had just spent that extra 15 20 minutes completing that drawing, I would have had the quote next day, right? So put your focus into those small things, do the small things really well. And when you talk about acceleration, right, if you can continuously stack up 0.1% improvement or efficiency gains, that 0.1% over the lifetime of a project, it's going to compound exponentially, right? And so if you can do that every single day and you make it a habit, I'm going to continue to do these small things every single day, your overall game, right, your overall result is going to be so much better.
There was I'm going to get some of the details wrong here, but the general um, high level message is accurate. There's a British cycling team. This was quite a while ago. I don't know, 20, 30 years ago, something like that. And within the world cycling circuit, this British team was pretty universally considered to be one of the worst teams in the world. And everyone knew it, and they hired a new coach to help improve this team. And the focus of this coach was not to make drastic overhaul changes to the team or how they trained. They focused on 1% better. How do we get 1% better here, and then 1% better there, and then 1% better there? And I wish I could remember some of the specific things they did, but none of them were earth shattering large changes. They were just really small tweaks. And over time, like you said, Brad, they compounded. And that British cycling team became a true contender. They were one of the top teams after, I don't remember what it is, a few years, but in a shockingly short period of time, they climbed from being one of the worst teams to one of the best teams because they focused on 1% better, every day, just trying to make these small little changes that compounded over time.
There's so many stories like this in sports. Bill Walsh with the 49ers back in the day. He has a whole book that he wrote about how he took the 49ers to becoming that championship dynasty right in the 80s and 90s. It's interesting to me because in sports this is so apparent. It's something that it's so tangible that can be seen, whereas in engineering this is a point that's not super tangible all the time, but it's one of the keys for yourself. If you can convince yourself that these 1% improvements are going to make you better, going to make you faster, more efficient over time. You talk about how can I get ahead, or how can I be faster in my career. That's what you need to focus on, right? It's not about getting another degree, right? That's like a big 20% part of the pie, right? If in that time that you spent getting your degree, if I just spent a bunch of time getting my 1% down, I've surpassed you already, right? And so I think it's really important that again, this is done so much in sports, to really take that lesson and apply it to your engineering time. And I think it's becoming more and more apparent that that's what is going to set you apart.
Right. All right. Well, everyone, thank you for listening today. And we will see you soon on the next episode where we do part two of two, or part two of three of this How to Accelerate the Speed of Engineering mini series. See you then.
All right. See you guys.
I'm Aaron Moncur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services, visit us at teampipeline.us. To join a vibrant community of engineers online, visit thewave.engineer. Thank you for listening.